So in this video, I'm going to graph tangent function, okay? So when you have a function in equation and we need to think about what kind of x-axis and y-axis do I need to draw for this graph. I provided you the grid paper here, but if you don't have one, you need to use grid paper and you need to label x-axis with the numbers. These numbers are angles. So these numbers are angles in radian mode, okay? Y values are height of the function. So let's see what is all characteristics of this, and then let's use the graph paper. So to graph, I'd like to see the period. Is it possible to see the one cycle, one period from the equation? No. So I need to use frequency. Frequency is the coefficient of x as an input, okay, inside. So this is pi over 4. And tangent function has period. Parent function of tangent function has period of pi. So formula is like this. To find the period, you need to calculate pi divided by frequency. So I will do pi divided by pi over 4. In other words, pi division, change it to multiplication, flip this as a number, okay? 4 on the top, pi on the denominator, cancel, cancel, and 4. So we calculate period, and this is the period, saying that one cycle will be appeared in 4 units. So if I start from 0, one cycle stop at number 4. And second cycle start from 4, stops at 8, like that, okay? So by using this, and I can graph 1, 2, 3, another 4, right? So I can graph about 3 cycles. Make sense? So you need to find one cycle length, which is called a period, and have more than that. If the direction asks you to graph more than 2 cycles, times 2, and I need at least 8 units on the number line, okay? Period is 4, so I don't need any numbers in terms of pi. So it goes by 1, 2, 3, 4, 5, 6, 7, 8. The other side, -1, -2, -3, -4. That's angle rotation, right? Negative direction. So that is the format you need to have for x-axis and y-axis. For y-axis, I need to see vertical stretch or shrink, okay? Is there a vertical stretch or shrink or compression? No, the number 1 is invisible one. We don't call this number as amplitude in tangent function because tangent function is not a wave function. There is no amplitude going up and down, okay? So we will think about that. So we call the first thing, number 1 in front of this is called vertical stretch or shrink. It's 1, so nothing happened, okay? There is no stretch. No stretch, no shrink. So let it go. All right, so let's look at the factored form inside of the input. Tangent blank, that is the input value. From factored form, we see x equals to 1, right? And then this will be 0. So you're looking at number 1, okay? So this is phase shift in trig functions. Or you can say horizontal shift, okay? Same thing. Is it going to the right or left? +1 is the number we look at because the format itself has negative in it, okay? So we are using number 1. 1 to the right, that is the phase shift. So instead of graphing from 0 to 4, I need to push it, so it will go to 1 to 5, 5 to 9, like that, okay? The pattern goes like that. And the last one, we have a +4 after the in function here that is related to vertical shift. It's going up 4 units. We follow the same sign. So that is going up 4 units. So let's see parent function of tangent function. Tangent function has parent function like this, passing through 0, 0, and there is a vertical asymptote at negative pi over 2 and pi over 2, and the graph on the right hand goes this way, approaching the vertical asymptote, but it never touches. And the other side, concave down, and it is going down, 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 following the vertical asymptote. So that is the parent function, okay? And absolutely, this is repeating again here, because tangent function is also the periodic function. It has period. So we will use this point as point of inflection, concave up, concave down, changes, and that is good point to use it. So I'm going to move that point. This point to the right one, 1, 2, 3, 4 up. So that point positioned in 1 and 4, 1 and 4 transformation, okay? And after that, since the cycle is 4, 1, 2, 3, 4, cycle after that, it appears again. Same thing. 1, 2, 3, 4. After the one full cycle, we see that position again. The other side, 1, 2, 3, 4. Yes, we will see it there again. Okay. And where would be the vertical asymptote if we have a position point there? And this is another position, right? Can I take half of those points? Why not? Let's see. What is the point in the middle? Okay, here. So one arm goes upwards, the other arm goes downwards, right? So I need to divide it equally into half. There is a vertical asymptote. Okay, so we have vertical asymptote. Are you drawing on your paper? Okay, now let's draw the arms of the tangent function. It's not reflected and it is not scaled at all, so I don't need to calculate anything else other than the shape, right? And my drawing is not going to be accurate, but I just use only these points as reference points, okay? Other points, it may not exact, so excuse those points, okay? And if you really want to do it well, you can use calculator for finding those values, okay? So you can graph it. All right, so it's not going to be accurate, but anyway, I will draw the shape, okay? That's it. That point I plot on the curve is the exact location. But other curve, just let it go. Okay, like that, okay? Oh, it's not exactly the same shape, right? But let it go, and that's it. Okay, like that. And then this side only goes upwards, right? So that's the graph. Make sense? All right. That's it for tangent.